All right, everyone. I am here with Doug Burdick. Doug is a principal research staff member at IBM Research. And Doug and I will be speaking today about making documents more easily consumed by machines. Doug, welcome to the TWiML AI podcast.
Thanks, Sam.
Looking forward to jumping in here. In some ways, this conversation is a follow on to my recent chat with your colleague Yunyao Li. And that conversation focused broadly on productionalizing NLP in the enterprise. And today we'll be digging in a bit more deeply into the work that you've done to make documents more machine consumable. And in particular, your focus on extracting data from forms. To get us started, I'd love to have you share a little bit about how your background in information retrieval led you to work in NLP and document conversion in particular, and how that informs your work.
Yeah, so really, what is the work that Yunyao was describing, and a lot of the work that our group actually does traditionally, we'll say, was actually around natural language processing and entity resolution. So we've developed all of these pipelines. Once we actually have the information in a unstructured or say a semi-structured form, like say HTML or XML, we can actually do the downstream processing of that. So that's what she was describing. Now, actually, the issue that we've had, so we were applying a lot of all of this work to data from the web. So, for instance, there's a very good corpora of financial data in, say, HTML forms. If you go to, say, the US SEC Edgar, there's all of the filings for every publicly traded company. It's available in an HTML form, which has the tabular data that you can actually process and build a knowledge graph from that. So that was the original project that we were working with. And then also there's other web sources like say wiki tables and so forth as well on the web where you're given the data. It's in an HTML form where you actually have the table metadata given to you. So then we actually had a request to actually try to extend our knowledge graph work from the financial domain to PDF documents. And this was the problem that we ran into 7 years ago was how do we actually apply that same downstream technology to data from PDF? One thing I think people don't realize about PDF is that it's actually an archival format. So it's a format that it takes, even if you have like a Word or an electronic document, you save it to PDF, it strips out all of the metadata about the structure of that document. So if you have a table from like a Word document, you save it as PDF, all of that table information is stripped out. So all you get from the PDF is just a set of characters, or you get graphical elements as your input. And if you also wanted to apply this to say a scan document that's an image, you don't have any metadata. And the thing was we needed a way to actually get this data into a form that could be then processed by all this NLP technology that we've been developing. So that's how we actually came into this problem. And we started looking at, say, even because this wasn't something that our group does. So we were trying to see if we could actually leverage something else to do this. And, we found out that there really wasn't any good solutions. And this became a research problem kind of accidentally in of itself. And now we've been doing this. So that was 7 to 8 years ago. And then I've been doing this now, and there's a whole team of people actually, both in the product organization. So I work with a team both in a product organization, transferring the work that we've done in research into the products, making it a product and then actually getting it into different IBM products and offerings.
Awesome, awesome. And we've talked in our prior conversations about a specific example that may be useful to discuss now to help contextualize this. This is some work that you did with the Allen Institute for AI and a COVID data set that they were curating. Can you talk a little bit about that one?
Sure, of course. So actually, they kind of had, so the Allen Institute for AI had the same problem that we ran into in that they had the Core 19 data set. So it's a data set that the Allen AI Institute put together for it was documents around COVID-19 coronaviruses from PubMed. So they actually got it's about 130,000 documents. So these were all journal articles about coronaviruses and COVID-19. They had that corpus, but they were all PDF documents. So they were able to pull the text out of the PDF document, but that was what they were making available for downstream processing. So they had the original PDF, and then they also had the text available, just the text. And the thing about research articles is a lot of information in those articles is actually contained in tables. So you'll have a table of scientific, of the results of the experiments or something. And it's better if you can actually pull that table out in some structured form so that you actually have all of the columns identified and all of the rows. But that wasn't available in this Core-19 data set. And it was actually something that was actually requested because the Core-19 data set had a Kaggle challenge associated with it as well. And that was the thing that the people working on the Kaggle competition were saying, hey, it'd be really useful if you could give us the table data in these from these PDF documents in this Core-19, just not just plain text. So we actually had some connections with people at AI2, and we actually told them about the technology we were doing for identifying tables and PDF documents that we had available, and we offered to help add that table data to the extracted data from the PDF documents. So that would be made available to all of the researchers who were analyzing that data set. They could actually then analyze the tables as well. And that was, that was actually the most. It was amazing. It was the most requested feature, like to be added to that Kaggle data set, was the tables, and so that was really nice that we were able to help with that. And it had a lot of impact on making that Core-19 data set usable, and it was a timely problem.
Well, let's dig into what makes it so difficult to get that data out. I think you've already mentioned one fact which I think is surprising. Yeah, I guess you would think there's more structure inside a PDF than there actually is, and it sounds like in some ways you just kind of treat it as a almost like an image. Maybe elaborate on on that, but then kind of continue on to some of the other problems that you run into.
Yeah, so I think the biggest problem with the PDF is that the format. So it's an archival format. And that's something that, again, if you were to talk to people from Adobe who developed the PDF standard, they would tell you, well, that's okay. You were never really meant to analyze these documents. They're meant to be rendered on the screen for human consumption. They're meant to be stored for archival systems of record and not modified. But it turns out that there's 4 trillion PDFs, and hundreds of billions more being created annually and all that. So that number is going up. And just like any data source, you know, people will want to do analysis over that data for new novel applications. So being able to add and have more information in the native PDF format would be useful. And that was something that, even if it was to be added tomorrow, and again, Adobe's thinking about new versions of the PDF standard that may actually include metadata. But that's still not going to make the problem go away, because there's still several trillion of these documents in legacy systems over decades that will have this issue. So really, and again, I think what you said is actually, Sam, is exactly right about, we have to treat the PDF effectively as an image, because if you think of it's how you as a human visualize the content there, that you're able to look at that page. And if, again, even my 7-year-old son, if I was to give him a document page and ask him to point out where the table is on that page, it's something that he can do intuitively, because there's visual clues of where the table is, and alignment of different text into columns, and there may be lines delineating cells and all of that. But it's something that it's very hard to take that, that contextual knowledge, like if I asked him how did he actually figure it out, he'd
Yeah.
just say, well, I know it when I see it, right? But that's something, how do you actually encode that into something that a machine can actually automatically do? and
Kind of
and
a
that's
classic deep learning, what is a cat kind of
exactly,
problem.
exactly. So
Yeah.
so this has been addressed historically. It's in the document intelligence community, document processing community, and also a lot of, then we'll say with deep learning, the more modern approaches are now deep learning based, because the computer vision community has now gotten more involved in this. And then now we're also starting to see the NLP community. So as we go further downstream, because of it started with the document processing community historically, optical character recognition, processing images, treating it as an image. If you treat it as an image alone, that will get you so far, because so you're limiting yourself to a feature space where you're just, okay, I'm looking at the formatting of the text, its position on the page. But now if I actually want to start looking at the content of that text, and then leveraging some of the other models for beginning to interpret that text along with the visual clues as well. So now you're kind of thinking it as a multimodal problem. How do I actually bring those together into a multimodal solution to actually bring, because that's what you're actually doing as a human, whether you maybe realize it or not, is you start with the visual clues that will take you so far. So if I was to say if you were looking at a document in a foreign language, you would be able to say, okay, yeah, I kind of have an idea where the tables are, just based on the visual clues. But then if I actually wanted to handle the really complex tables, I probably need to understand the language that the table is in, to make sure I've gotten all of the header rows, for instance, at the top of the table, making sure that they're included, and making sure I get the complete table, for instance, and also getting the structure of the table right. That's something where you actually you need to be able to interpret the values that were being identified from the text. So it's bringing the two of those items together is really, and that's where the state of the art in this area is heading, is towards bringing those two together, not just the vision and the by itself, but as vision plus NLP, and bringing that together into a multimodal solution.
Okay. Yeah, I
Yeah.
was going to ask before you elaborated on that. Hey, if it's just picking tables out of images, the kind of this classic identify a cat deep learning problem, like we could
Mhm.
probably do that with a supervised approach. We've got enough documents with tables in them that are probably identified. Maybe we need to label them or curate a data set, but that sounds easy enough. But I think you're speaking to, there's more to the problem than just identifying the table to turning it into useful information. And the way you get to that next step is by combining the visual features that you get with the NLP that's interpreting what's actually in the table that you identified.
Correct, but I also just want to back up one just briefly
Yeah.
about actually how do you, so for deep learning methods, there are, it's a supervised method, and you need a lot of data to actually do
Hmm.
this well. We're talking tens or hundreds of thousands of examples, and actually the largest data sets that were curated for this problem were literally in the hundreds or thousands of documents, because,
Really?
well, so again, so this is a,
Yeah.
a problem that's been, so decades of research in table
Hmm.
extraction. The problem is that those methods, up till very recently, the deep learning revolution, say maybe 5 to 10 years ago, a lot of the prior approaches were machine learning, logic, rule-based approaches. They didn't need that many tables to actually train those methods, we'll say the rules and the logical or the statistical methods.
Hmm.
Now when you go to deep learning, okay, now I need tens of thousands, hundreds of thousands to be really Sure. So how do I actually get those data sets? And this is something we actually um, did with there are, and this was actually also leveraging some of the Edgar data, that you actually have those annual reports that go into Edgar
Hmm.
actually are PDF documents that are available from different publicly traded companies on their websites. So they're submitted to the SEC as PDF documents. Then
But there's
the
also a structured XML thing that
Correct.
they
And then
publish as
somebody
well.
actually somebody has to make that by hand
Mm-hmm.
to
Okay.
go into Edgar. So what we can do is we can actually match up that structured XML that's available on Edgar, that somebody
Hmm.
hand curated or something to make that available, along with the original PDF. And then we can combine that together to get a labeled data set. So this is a
Hmm.
data set we is publicly available on IBM Developer FinTabnet. There was
FinTabnet.
also, yes, FinTabnet. It's about, it's like, I think around 80,000 pages where you have of the SEC data for the S&P 500 companies, where you have the tables with not only the border but the structure as well, because that's the hard one that takes a lot of effort to actually consume,
Hmm.
or to actually label, excuse me. The other thing is, we also, within IBM, this is also an IBM developer, we also have Pub Tabnet. And this was from there's a commercial use subset of the PubMed data set. So the journal articles there, so again, PubMed makes those journal articles. You have the PDF of the journal article, plus you have the hand curated HTML, XML output. So you can put the two, which has the tables labeled in it. So you can put the two of those together to actually get a labeled data set. That was another way we were, but now that's yeah, that's for, say, historical documents. It's not necessarily like some of the very recent journal articles.
Hmm.
But again, that's another data set we use to automatically label lots of examples.
Got it. But I think
And
one thing that jumps
mhm,
out is you've got your FinTabnet. That's based on the kind of these formal SEC
mhm,
publications. That's like one definitive style. Your
yeah,
PubMed, I'm imagining that's another
yeah,
definitive style. And what you haven't said is like tables in the wild, which is a large data set of tables just as they appear in random documents.
mhm.
And we know that deep learning can have challenges generalizing across different formats. So maybe how have you handled that?
Yeah. So how we handle that is, once we actually have, so you can think of it, there's a pre-training step and then there's a fine-tuning step. So we've
Hmm.
pre-trained the deep learning models on those large data sets that I was alluding to, FinTabnet and PubTabnet. Now when you actually want to, say, fine-tune it further for a specific type of document, say like invoices for instance, that's very different. Now, you will get a, you know solution from the table extraction as it stands, but you still need other labeled documents in it. But here it's actually a much lower number. So now we're talking, say, depending on how different this invoice structure is from what it's seen before, it still will generalize to the invoices and do a reasonable job. But even if you were to fine tune it further on, say, tens of documents, so tens of pages labeled, you can actually boost that accuracy dramatically. So there is a little bit of generalization if you just give it a few more examples specific to the corpus that you're looking at. So for that, we actually built this solution called Table Lab, which actually allows us to label a small number of additional documents, the board where the table is and the structure. And we actually had a paper on this at IUI in 2021, where this system lets you actually label a small number of documents. It supports that, and then it will actually do the fine tuning of the deep learning models. So then they're available for document processing. So we've done this internally, and we've seen, we can get the F1 scores to go up dramatically on these out of domain examples, just from labeling like 10 to 20 additional pages, which is not a lot of effort for somebody to do. So that's how we handle the tables in the wild.
You gave the example of invoices. Are you treating invoices as a broad class of documents, and you're fine tuning on invoices, from lots of different customers with different formatting variations and things like that? Or are you, this is a particular customer's invoices and the invoices that they receive? Like, how fine does your fine tuning have to be in order to be effective?
The thing is that so with a so if you have a collection of invoices that are coming from the like they were generated from the same template, okay, and then you are fine tuning exclusively on that same template, then downstream you will get better results because you're asking the deep learning to generalize less. However, as long as for that fine tuning you have examples of all of the templates, because so the usually these invoices there's a template that different different customers, different companies will use
Hmm.
for all of their forms, and and even with slight variation, you can even start clustering together these templates into actually like meta templates that people use, and
Hmm.
that's another active area we're also looking at as well, just to have pre-built models over different, just discover which templates being a meta template is being used, and then um, trying to identify which meta template and then leverage that model. But the thing is that as you will have to fine tune over more examples, because you will need examples for each of the templates, and as long as you have that, then it would still generalize and benefit from the fine tuning, even if it's a heterogeneous corpora. And I think that's part of the strength of this approach, is that because a lot of times, yeah, that's what we see in the real world, is that people will have it's heterogeneous collections of documents. So you can't treat a data source as a single data source. It's actually composed of multiple data sources with multiple formats, and you need to be able to handle those on the fly. Because that's where this whole area of document processing, automatic document processing, has moved from. It used to be define a template, then the document is from template 1 or template 2 or template 123 or something. Now you kind of have to be in a world where I don't really know what the template is ahead of time, that I need to try to still process the document despite that.
So can we maybe back up and talk about the what kind of the pipeline looks like?
Mm-hmm.
So there's, one step where you're using deep learning to identify the tables, and there's another step, and I'm using this the step very loosely. If you're doing it all in one shot, let me
Mm-hmm.
know. Or one uh end to end model.
Mm-hmm.
um I wasn't necessarily trying to make that distinction,
Right.
but there's one aspect of the problem where you're using NLP to
Mm-hmm.
determine what's in the table, and then can you talk about the different
Sure.
pieces there and how they all
Sure.
fit together?
The two big steps are what we call document conversion, and
Okay.
then we'll say the document understanding, which is the
Okay.
NLP. Okay. Now, within that first step of conversion, which is a pipeline by itself,
Hmm.
there will be a step where we actually just think of it as just basically pulling the basic data out of the PDF document. Also, if it's a scanned image, this is where we actually do the OCR step over that document to actually pull out any text
Yeah.
in the image. Okay, from that, so we have the text with its position comes out of that. Now that is what gets fed as input into this table identification step. So when we also
Hmm.
have a rendered image of the document page, whether it's coming from a programmatic PDF or whether it was the image originally, we pass that on. That's what goes into this table identification step. Now the table
Hmm.
identification step will actually it so within that table identification step, and this is we had a paper at WACV 2021 that goes over the table extraction process. But there's, at a high level, the deep learning component, it's a object detector that has actually been jointly trained on identifying tables and cells. So the key innovation there was that there's information from the cell identification that can help make the table identification better. And also table identification better, just looking for where the whole table is versus looking for individual cells within the table. So if you actually train those two networks together to get a joint model, that will actually do better than just doing those as separate pipelines, like find table first, then find cells. So actually doing those together actually is helpful. But the other thing is that the output of the deep learning step by itself, for object detection, it will output, here's a table and here's a collection of cells. But that's still not the business problem we need of get the table along with its structure. So to do that structure induction step, so there's another AI process after this that is actually taking the output of the object detection. So I have the boxes for here's the table and here's the cells on the page. How do I actually turn that into a table structure? So I actually have, here are the cells, here's their alignment, their row spans and col spans, like how these cells align together into a table structure. Then that is the output of the table extraction step. Then that table extraction step goes back into a final document. There's a final document output that puts everything into a text format. And then that text format is what gets passed into NLP. So then NLP will actually start parsing the table and trying to understand, okay, which cells in this table correspond to headers, for instance, because I have a body cell. So that body cell has to, gets its context from the headers, like that this is the units of measure, or this is also, I'm talking about income. I'm talking about income for the fourth quarter of 2020. I'm talking about, and then the context that this value is actually millions of dollars. That's coming from other parts of the table. So you need to put that all together. But that step of actually turning the table into a collection of structured facts, that goes on in the NLP stuff. So that's what Yunyao was describing in the other previous conversation, is that step, how we actually parse it and then turn it into a forum where we can answer questions over it. So that's turning it into a knowledge graph, for instance, and then using that for other downstream applications.
When you're at the NLP step where you've got kind of this rough table structure that came from your deep learning stage, are there, to what degree are you able to generalize there, to a set of table, APIs or table level functions, as opposed to, uh, you know, treating a specific problem discreetly?
So that NLP step, again, so this was something that we've been working on that longer. So we had been doing table processing from that actually now close to 12 years, because and again, this was motivated by that there's a lot of tables on the web, and making that generalizable, because we wanted that to generalize to tables on the web. And also, once we had the specific Edgar tables, I think the thing about, what's interesting about Edgar data from financial reports is that these are very complex tables where you have multiple levels of headers and headers that cover multiple columns. That's something, if you go look at Wikipedia tables, they're usually just, it's a grid with a single header, a single header row, just giving context to the values beneath it or something. The Edgar tables are just a lot more complex to actually do interpretation of, and we kind of made more progress. I don't want to say solved that problem, but we made a lot of progress on that, um, because of Edgar from the HTML. Then when the main problem just ended up becoming, okay, can we get the table out of the PDF with a certain level of fidelity. That
Mm-hmm.
that was a real challenge.
But
But
on
at
the
this,
on the NLP side, what is the what is the problem? How have you defined the problem? Is it, say for Edgar, you've
yeah.
got this complex table structure,
Uh-huh.
you are passing it through this NLP process.
Right.
What are you trying to get at on the other side?
Okay.
Is it, put it into a SQLite database so that someone could query it? Is it, some question answering kind of system? How did you structure
Okay.
that?
So it's both. So
Mm-hmm.
the idea at the end of the day, and even what we were doing with it was we were using it to populate a knowledge base or knowledge graph, whatever either
Right.
term people are using. So what you're doing is that table. You can think of it that okay, again, even as you as a human looking at a table, so that table will have in it, there will be data cells in the body of the table, and then like those that like that value 280, we'll say. Now how does that 280, like what does that mean? Well, then you look usually to the right, or excuse me, the left of the table. You'll see there'll be, okay, this is the income, so that will tell you that this 280 is an income. Then I look up to the top of the table. The first couple of rows are usually going to be something like Q4 2020, or something like where they're actually giving you that, okay, this is income from the fourth quarter of 2020. Then there might be an additional metadata somewhere in the table that these values are in millions of dollars. So that actually the income was $240 million for the fourth quarter of 2020. That now being able to turn that body cell into a structured fact, that would go into a structured fact, and then that structured fact, then you could put that into a knowledge base, and then you could use that for answering questions. Because like, okay, if you had, you wanted to ask a question, what was the income in the fourth quarter of 2020 for this company, then you could pull that information out of the knowledge base.
So when I think about complex documents, there, and the more complex features of those documents, tables are one example, but there are others like charts. Um, to what degree have you, have you worked on those, and where are we as a field with extracting information out of other types of semi-structured substructures in documents?
That is a great question, Sam. So actually, we actually have other people. So part of our work that we're doing on document conversion. So this is, there's different levels of, we'll say, maturity for the research, and that. So we'll say tables is a little farther along because tables is a little more defined the problem. Now, but however, people are asking about charts because charts are another way that people put information into documents. And also the other thing is also around flowcharts as well, that you'll have a process like in an engineering document, like going from A to B and then so whatever in a flowchart. How could you actually be able to interpret those? So I do have some colleagues at IBM that I do work with that are actually looking at charts as well, like being able to take that chart, here's the information in this chart, and turn it into a structured form that kind of would resemble the output of a table, we'll say. Then once I know how to process the data from a table, then I can leverage that downstream table processing in the NLP, because that's kind of how you take something that's visual like a chart and then turn it into a collection of structured facts that can actually then be processed downstream in NLP. So that's something. So chart identification is something we are looking at. That's something that's a little farther, we'll say, it's a little farther back in research. And I think just overall that area though is also a white hot area though in the wider research community as well. Is there's a lot of work going on with charts, and flow charts now is also kind of becoming important as well. Like these process diagrams, I think is the official term for that.
Maybe going back to the table problems. We've talked about NLP broadly,
Mhm.
but NLP has evolved quite a bit since you started working on these problems. And in particular, we've seen pretty broad adoption of transformer based approaches, and BERT and GPT X's, things like that. Um, to what degree are you taking advantage of those types of models, and where do they fit into your process?
So yeah, deep learning won the the war. That's sort of pretty obvious. The thing is that transformers are even starting to be used in some of the state of the art computer vision approaches. But I think the we'll say the bleeding edge state of the art in this area, just more generally speaking, what's out there, are approaches like say layout LM, which is coming from say Microsoft Research, where you're actually bringing so you're actually bringing in BERT and you're bringing in the NLP along with adding in some of the positional information as well. That's sort of we'll say the state of the art. So you're turning this into a multimodal problem where you're not just leveraging the traditional, say, the CNNs that the vision community use for object detection. I mean, object detection is one area that can actually, that inspired our research in a particular direction, and a lot of people have gone down that path, and it does very well, and it's giving the we'll say the state of the art. Now the bleeding edge is going to actually now end up being though bringing in these multimodal features. So you're combining together, or you're think of it like you're augmenting BERT with additional like the position and the formatting information and all of these additional features as well, and then that will actually do better on a lot of these problems that and it is already starting to show very promising results. So that's probably going to be the next state of the art area, is going to be these multimodal models.
Hmm. Is it fair to say broadly that one of the trends that you've seen in this space is kind of over time going from this multi-step, set of processes to, you know, you know, incrementally collapsing elements so that some end-to-end trained thing has greater knowledge of all of the pieces and can make more sense out of it?
Yes, that's what effectively is happening. That the thing is that so if you treat this as a vision problem by itself, you will go so far. And again, that goes back to that example I mentioned earlier, that okay, if I'm looking at a table if I'm looking at a document page in a foreign language, and I actually had to do this. I looked at it was in Mandarin, looking at the document, and yeah, I can identify roughly where the table was. I had no idea what I was looking at, but I could identify that there was a table on the page, and give a rough idea of what I thought the structure was. But if it's a complex table, understanding those characters. So the example, if I took a off the shelf object detector, it would be like a human looking at a document in a foreign language that they don't understand. So that will, you can do a good job on say the easy to intermediate level cases of pulling out a table. Now, if I really want to pull out the really complex tables, this is the cases where where does the table begin and table end, because it blends in with unstructured text on the rest of the page of the document. Also, I have charts and I have other things that look like tables that really shouldn't be detected as tables. How do I actually, if I want to actually make sure I get a high fidelity solution for those cases, the complex cases, I will need to understand the text on the page. So then, so that's actually what bringing in these NLP models is attempting to do. I think the thing also, just my own experience is that digging into this, that there's a lot of people in the document understanding, or well, the document processing community, that there is some natural overlap between them and the computer vision community, because computer vision, OCR, and that historically.
Mm-hmm.
Then now it's getting the NLP community. So a lot of the now you're getting people from the NLP and the in the data management community did some work on web tables, but now it's bringing those four communities together, kind of into this problem, and kind of making sure that they all understand that there's really one big problem that everybody's trying to solve, but it's kind of the about the elephant, right? Getting to the element of document, or the elephant of document understanding. Everybody's been grabbing, like the vision community grabbed the trunk, the NLP people are looking at the tusk, and somebody else is grabbing the tail. Making sure that they can come together, and then the expertise of these different communities to actually solve this problem of document understanding. So that's something that we're we strongly advocate, and when we're publishing, and that's why we're going to different venues. So I did a document intelligence workshop at KDD. I've also done I've published on this at VLDB. We did a tutorial, a conference on data mining, ICDM. So we're going to different venues, and trying to advocate that, hey, this is an interesting problem, that and there's different aspects of this that other people can become involved with.
Mm.
So yeah,
Awesome. Awesome. Can you speak briefly about evaluation and the way that that figures into attacking these problems?
there are some very widely used metrics that have come out of the document processing community, so that, and how they what they're measuring, it's, and this is maybe something kind of general to AI overall. It's making sure what you measure, and what you're how does that align with the actual business problem that you're attempting to solve. Because again, the business problem downstream that we're trying to solve is, I want to turn this table into a collection of structured facts. So for that, I need to have you know the complete content of the table, but I also need to make sure that I include the header cells at the top of the table and to the left of the table. I need to make sure that those are included, and that the structure of the table is overall pretty sound. Now, a lot of the metrics I'll just speak specifically to table extraction, the metrics that are widely used, they don't really penalize tables that cut off the top of the table, the header cells. They're measuring something different about getting the structure of that table. So the problem is that you have a very large table, we'll say with like 100 rows in it, but I chop off, say, the top 2 rows. So I would say, okay, I get 98% accuracy because I got 98 out of 100 of the rows correct. But if I go to try to turn that into, like, process that table downstream, I actually have 0% accuracy, because I can't interpret the table. I just have a bunch of rows in the table, and I have no context for these values. That's something that, again, we've also been strongly advocating, that making sure that there are metrics that the functional values. So it's these functional metrics of being able to downstream process this table, that those are actually reflective of what people want, and making sure that advocating that systems, both academic and industrial, that if you're doing your evaluation of this, really the most useful evaluation is going to be those functional metrics, like where you actually are making sure to measure that I can take this table structure that you give me, and I can actually process it downstream. That's that's something, and again, unfortunately, I think we're also seeing this in some other areas within AI, NLP, and that is just making sure to be very careful about what you're measuring, and making sure that that aligns with the actual problem that you're trying to solve downstream. That's something, to get on my soapbox just very briefly, that's something that I think we all just need to be aware of as we go forward.
Maybe going back to the motivating example that we started with, the COVID data set and the Kaggle competition around that, you know, when you've got this corpus of semi-structured documents, like, text plus data, um, do we do we know what to do with that? Like, does NLP itself know how to deal with this combination of text plus data once we've extracted the text in all its, I'm sorry, the data in all its richness, or does that field also need to evolve to better accommodate the kind of multimodal data?
There has been a lot of research in the NLP community about once you give it the structured text, being able so you get the tables identified and the unstructured text, being able to use the unstructured text to provide context to the table, and being able to process the table content. So there's been a lot of work around you know question answering and knowledge base creation and so forth in the NLP community. But I think one thing the NLP community maybe doesn't quite focus on, or hasn't focused on, is understanding where those tables come from when you because if you're getting tables from, say, these PDF or images, it's going to be a little different than web tables. It's not going to be as perfect as the web tables, so you need to have a little bit of robustness to errors introduced in that first step of the process. And then the second thing is just making sure you're dealing with the complex tables where the headers, the alignment of the headers isn't necessarily easy. That these are not just little grid tables, that these are tables where headers span multiple columns and there's nested headers and so forth.
So it's its own line of research that's fairly mature, but as we get better at pulling complex information out, it
Yes,
needs to evolve accordingly.
precisely.
I think we've kind of covered a lot of the future things that you're looking at in terms of, what has to happen in NLP, incorporating graphs, things like that. Are there other aspects to this problem that you see ahead of us or that you're excited about tackling?
So I think the biggest, I think the biggest items are going to be just bringing together the visuals into the document processing. And also it's also, I think the other thing is going to be how we actually get the data, because the idea that something where the understanding, where somebody just can label something at a very high level, um, maybe not even understanding what a table is, but just start, giving you, here's the facts that should be coming out, and then correcting the facts that are being extracted incorrectly, and then being able to leverage annotation at that level, because that's really, the ultimate end goal vision for this, is that, you know, when the system does something, you get the final answer, and then they're able to actually just say, no, this answer is not correct, and then you can actually pull that back through all the different stages of the pipeline and try to fix the pipeline where where did this answer break. Like, why did we get the wrong answer? I think that's the thing that's going to really make these systems usable, just in addition to processing different types of visuals and so forth.
Got it. In a lot of ways, that sounds like a continuation of the theme, like, end to end models, end to end evaluation, end to end
Yes,
labeling. We need to think about the problem as a whole, and
yes,
that will help uh, advance the field or push us forward in solving it.
yes, yes, because this is inherently a pipeline, and
Hmm.
even though it's a multi-stage pipeline, it's a pipeline that has back arrows in it,
Right.
and also some things you might doing in parallel that they can share information and leverage. I mean, even something as specific as table, like identifying where the table is, and then the cells, that the, doing those two steps in parallel instead of doing them one after the other, that
Hmm.
actually improved performance. And that was just, it's a very specific example. But then
Yeah.
also, the how do I identify the headers, being able to bring in some table understanding into that process, as well as, like, say, a third thing you're doing in parallel that can
Hmm.
help. Just something specific as table can benefit from that, and then as you're going into the more broad problem as well. Yeah.
Awesome. Awesome. Well, thanks so much, Doug. It was great learning a bit about what you've been working on.
Great. Thank you, Sam. I enjoyed it. Enjoyed the conversation.